हेलो सोनिया। ऐश्वर्या, मोनाली, स्नेहल, प्रीति, nobody is answering. हेलो मुकुंद, मुकुंद, ओंकार,
जी
हेलो
बोलिए।
ओंकार।
जी बोलिए मैडम, सुन रहा हूँ।
हाँ, रिवीजन नहीं ले,
आपकी आवाज
बच्चे कम है ना।
नहीं, आपकी आवाज काफी रुक रुक के आ रही है।
रुक के आ रहे।
हाँ, रुक रुक के आ रही है, धीमी से आ रही है।
ओके, बट स्टूडेंट्स आर वेरी लेस। कैन मैं
नहीं, इसके बारे में मैं कैसे बता सकता हूँ, मुझे नहीं मालूम क्यों ज्वाइन नहीं किया है उन्होंने।
नहीं, क्लास चाहिए कि नहीं, क्योंकि 25 हाफ ऑफ द स्ट्रेंथ भी नहीं है।
नहीं, क्लास लेने के लिए इस बारे में मैं नहीं बता
स्नेहल,
सकता। आप क्लास रिप्रेजेंटेटिव से पूछ सकते हो।
मुकुंद, प्रशांत, कोई तो बताओ। ठीक है, खुद का अपना करूंगी अभी। is not Can you see the screen now? Screen is visible. पूजा प्रणाली कोई भी नहीं बोल रहे, ठीक है, मैं अपने आप बात करूंगी. Okay, yesterday we have seen this example, and as we know, the identifiers, that is the variables and the labels, are pushed into the symbol table. From symbol table, after the end of the from trending, they will be pushed into the symbol table to find out or to resolve completely the object code. In the next, once the all the code, once all the lines of the source statement of the assembly language is finished, the declaration segment will provide the location counter processed for the identifiers and for the label, and the elements, the most important assembly language program elements are the origin, EQ, and Delta-RG. Means the advanced assembler directives are the elements of the assembler, the elements of this assembly language, and the location counter processed for the location to be processed for the literals where are in the literal table, and origin will give you the address the address for the it will set the address for the address specifications mentioned in the brands specification. The origin will give you the address for to set for the next next line of code. So for example, lines contain the processed and plus one value of last processed value that will be for next, that will be for the next whatever the line of the source statement of the assembly language will be there, that will be set to that. So this was all about. Now let us look into as I was saying, the origin, as I was saying, the variant, two variants we have seen, the differences among them, variant 1 and variant 2. The main of variations, there should be some changes in the code by picking during the pass 1 and pass 2, so that equivalent of the pass of Sorry, again the connection was lost. Okay, that was all about the assemblers. And if you want any, am I audible? Am I audible?
Yes, ma'am.
So if you want any the exercise questions, so this for this example also you can try, you can note down. That time also I have told, and this is another example where you can try for the assembly. I mean object code of this assembly language. So the next we shall start for, but before that let me show you, because after knowing let us see the algorithm also. How is the algorithm? So as the location counter is by defaultly it is a 0, the first value of the location counter, and in the first pass what does it happen, we know it very well that it all the identifiers which are found they will be pushed into the symbol table, and all the literal values will be pushed into the literal table, and also they will be detected as the pool table also will be there. As I have told you, should be known what is the difference between the literal table and the pool table. See here once again, this is the literal table, whatever is found in the source program, the immediate values are nothing the literal values, and these literal values will be pushed down to the will be kept into the literal table. And how the pool becomes, as you pool is nothing but whatever the littles are being found by our LTORG, are being found by LTORG, till there only the littles are being detected, and their location counter is also processed. Now in this example, here is the literal, first literal 5 and the second literal is 1. So the same thing is pushed here in the literal table, 5 and 1. The first is 5 and second is 1. Then to time being this 5 and 1, as I come to 6th line, as I go to sorry, as 5 is detected, so it will be pushed into the literal table, and this its value of 5 to 11, time being it will be kept dash after the forward reference is during after the forward reference is finished, the location counter of this 5 will be identified. Now how it will be identified? For all these literals, we should use, the programmer should use to have their address specification, the programmer should use, or the assembler will defaultly it will use at the end of the statements, after end of all the lines. But if they are not if the programmer, if the programmer will not specify the address for them by the LTORG, I mean programmer will not specify the address, the assembler will specify. Of course the programmer need to specify here as LTORG, literal origin. Will start here by saying as literal origin, so that 5 and 1 will be processed by the location counter, so that they will be having the address specification as 211 and 212. So till then it will be here blank only, till then it will be blank only. So a programmer whenever he want, he can do that in the middle of the statements, in the middle of, else if the programmer is not at all doing this LTORG for address specification of 5 and 1, assembler will take on its own defaultly at the end of the statement. Now as you come, okay, till here assume that we have finished, and one more here, immediate, I mean the literal value is found here. So that for this literal value again, after here to generate the object code for this line again, 2 is the subtraction, ARG is 1 and 19 is nothing but 219 is nothing but what it is being processed, and that is LC, what the LC is being processed for this one. So time being it will be dash only. How 219 will become means, here if you observe here LTORG nowhere it is specified, nowhere is specified. So the programmer, if he has not given no in any of the middle of the line, so the assembler will take automatically for giving the address specification for the literal. So here at assembler at the line called as 25 has taken on its own and has processed the line as 219, because end is program end is finished, program end is, and for end and start we don't declare any. For end also it will be 218 only. For start and end we don't declare any location counter will be processed. So here for one which is left out, so it will be processed as 219 and its object code will be generated. So this one is the second phase. This one is the second phase. So the same value, how that pool will be having, pool will be, of course this one is the fresh value, this one is the fresh value, but it is entered at the third time, but it is first time 5 is entered, second time 1 is entered, and also the third time the 1 is entered. But till here first and second, the first and second, that is 5 and 1 were declared by LTORG. Declared in the sense they were processed by LTORG. By using the LTORG, the address specification for 5 and 1 was allocated, and now at the end of the line it has to be processed. The assembler has to do the processing of the address for 1. So it is a second pool. So it is a second pool. So what does it happen? The second pool is at 3. Therefore here hash 3. In the first pool or in the first literal number were 5 and 1. At where they were at 1, it was beginning at 1. Maybe it can be many more rows here, many more rows of the first literal number 1. Assume that 5 1 something like 6 7, and after the four values at fifth place the second literal value is started. So for that started in the sense the LTORG is being defined only for, assume that certain literals only. So after a certain literal again one is declared, but it is not given by LTORG. So the assembler will take on its own. Once the assembler will take on its own, that specification will be allocated here. But it is at which place? But it is at which place? At the place called 3. So hash 3. Hash 3 is the literal pool. So let us look into the algorithm once again. So location counter is 0 and the literal pool is indicated by 1, and the literal table is also indicated by 1. They are and they will be incremented, because as the values are found as as the values are found as the literals, so their values will be pushed into the literal table. While next statement is not an AND, so during that period, if a label is present, so that will be pushed into the symbol table and enter this label in the symbol table. And if LTORG is found, means it identifies that, declares the location counter. So it, how does it process the location counter? How does it process the location counter? It allocate the memory and put the address in the address field. And meanwhile it also process for the pool table by incrementing 1. Why? Because the literal pool also has to be checked meanwhile, whether it's a fresh value or whether it is the same we are doing like that. And if a start or origin statement is found there, then what should be done? If a start is there, the location counter value specified in the operand field, that we know that value value specified in the operand field. If equal to some advanced directives are found. So if they are found means what is the value of the previous label, the same value will be given to the any other what it is any other label what it is been equalized. So correct the symbol entry and this label to this label to this address means make them equalized. If any declaration statement is there like a is declared by ds and we need to specify its size and also the location counter will be increased and also the if it is there dl sometime dl we use sometime we use intermediate code. So dl means data data I think dl I have told uh, declarative statement. DL is nothing but a declarative statement. So you can see here in the code here I have used as DS not the DL. DS data storage for A and data storage for B. DL is not used here. Declarative statement. If imperative statement means any simple statements, who can be imperative statement like add, move, sub. So such things are called as the imperative statement. If in a assembly code, if imperative statement are found, if in a assembly code, if declarative, if declaration statements are found, what it has to be done, it should give the declaration for code size. Also, it should increment the location counter and generate the intermediate code. And if an intermediate if an imperative statement is found for that also what we need to do find its opcode value and increase the location counter. How you have to increase and even you have to check with the operation table and if operand is the literal so get into the literal table if operand is found. If there is else if there is an operand in the symbol table and that operand entry it has to check okay whether all the symbols are finished or not and if there is a end it indicates it indicates that it has to go and perform the step 2 of the B part. Let us say the step 2 this is the step 2 of the B part because step 2 of the B part in the sense if the end is seen after the end it has to check for any literal table. So step 2 of B is nothing but here LT or J. Such things it has to assembler should see and generate the intermediate code and also go to the pass. So in this way the algorithm of the assembler is there. Now let us see the macros. How the macros are, as I said you what are macros. If you even if you see this figure here also you can understand how the macros are at the beginning. I have told you how the macros not here in this slide, I think in the other slide. Hmm. Any source program to be accepted by the high level language. So before that file inclusion and before that header files detection will be there and that is done by we call it as a macro and that is accepted by the I mean such C file will or such a high level language will be accepted by assembly language. Then rest remaining code and after defining their macros rest remaining code will be compiled by the compiler and it will generate the assembly code So let us see the macros now. What are macros? Here some solved questions which I have not solved. something very beginning of the class I have kept here. It's some lexical expansion and some semantic expansion. So here you just see the, the figure. I have just done some scrap here. As you have the source statement, that source statement is of your high level language. It can be treated as the C level language or C++, and that language has to be compiled. And before compilation, here macros will be there. That program will be with macros. Assume that macros here are nothing but the header inclusion files, and such macros will be solved by expansion macro. And after the expansion of the macro, the rest remaining code, whatever is there, the high level language, it will be converted to the assembly language by the compiler. And this assembly language, by the generation of the code generation, the assembly language will be converted. And the assembly language, whatever is converted, is accepted by the assembler, and the assembler will produce, and just now we have seen, it will produce the object code. It will produce the object code, and what the linker will produce is, linker will produce the exe file, executable file, and this executable file has to fit into the memory for execution. Has to fit into, and it is ready. This shows that it is ready. So the executable file has to be loaded into the memory. And to load into the memory, different types of loaders will be there: absolute loader, relocatable loader, and relocate and linking loader. The three different types of loaders will be there, and bootstrap loader. So many more like such types loaders will be there. The exact aim or the main agenda of loading the executable file into the loader only just because for execution of a file. Here till here the file will be with so many subroutines of the main program, and that will be linked to produce the executable file. Now, how the macros look like, and macros, what are these macros? In your simple example, macros are nothing but the pre-processive statements, and they are also, as you are seeing, they are also nothing but the file inclusion statement. And macros may be used to provide a program generation facility through the macro expansion. And many programming language provide built-in facilities for writing the macros. Yes, we do, right? As you have seen many more examples in the assemblers, so we do write many more macros. The exact picture of the macro, how it is, you can see here. The name of the macro is SVERI is the name of the macro, and this is the macro code what I have taken there. And the name, this name of the macro is called here two times: strg strg. Wherever it is called two times, and it will be substituted here. It will be substituted here by that substitution. We say it as macro expansion, which I have shown here. Two times it is substituted. STORG. How STRG is? Store A, store B, store X is like this. Okay. Uh, store SRG. STRG is the name of a macro, and that macro was called twice here. So this is called as calling macro or macro calling, and this is the macro definition. This is the macro definition, and this is the macro expansion. How does it does expansion? After this only the assembly, now it is ready to be taken up by the, now it is checking for the macro taken up by the compiler. Compiler will check for rest remaining part of the code. This is just a part of the program. Macro is just a part of the program, and this macro, after the solution, after resolution, it will be generated. The whole program or the whole statement of the high level language will be generated as the assembly code. Will be generated as the assembly code. Now here you can see the same example. Macro name will be there here in bracket, plus square bracket I have used, and here macro definition it is called as, and end of the macro definition. Here macro name is incr, and this is the definition of the macro, and here end of the macro, and this incr is called twice, that is called as macro call. And how would be the macro expansion? Now you are seeing here the name of the macro is wd, and this wd is called for 3 times, and it is a macro invocation. Calling macro is also called as macro invocation, and it is called for 3 times. So here you can see how the macro is getting expansion or is getting substituted for 3 times, 1, 2, 3. This is called as expanded source program. This is called as expanded source program. Now what is a macro? Macro is a unit of specification for a program generation through the expansion. What it is? It is a unit of specification for the program. Of course, it is a unit of some bunches of program or some bunches of statements are there in the program, and those bunches of statements to avoid the multiple writing of the source code wherever it is necessary. So that time we are using the macro. That time we are using the macro. So remaining macro definition, macro algorithm we'll see in the next, not definition, macro algorithm we'll see in the next class. Here I have some type of macro. The type is not that much important for you. It is only required for you to know how is the design overview of a macro, how the designing is of a macro. So the design part of a macro we shall study in the next coming classes. And we also need to know how are the nested macros. Here certain example I have taken how is the nested macro. Macro in a macro. This is one macro, and the name of the macro is here it is called, and here again it is called macro in a macro, end macro. Okay, we shall see in the next class. Roll number 1, 2, 3,
Present, ma'am.
4,
For present, ma'am.
5, 6,
Present.
7, 8, 9,
9 present, ma'am.
10, 11, 12, 13, 14, 15,
Present.
16,
Present, ma'am.
17, 18,
Present, ma'am.
19,
20. 20 present, ma'am.
21, 22,
22 present, ma'am.
23, 24,
Present.
25,
Present, ma'am.
26,
Present, ma'am.
27,
27 present, ma'am.
28,
28 present, ma'am.
29,
Yes, ma'am. Present.
30,
Yes, ma'am.
31, 32,
Present, ma'am. 32.
33, 34, 35,
Present. 34 present.
36,
Present, ma'am.
37, 38,
Present, ma'am.
39,
Present.
40, 41,
Present, ma'am.
42, 43, 44, 45, 46,
Yes, ma'am.
47,
Yes, ma'am. 47.
48, 49,
Present, ma'am. 49.
50, 51, 52, 53, 54, 55, 56, 57, 58, 59,
58 present.
60,
59, ma'am.
okay, 61, 62, 63, 64, 65,
Present.
66, 67, 68, 69,
Present.
okay, 70, 70. The absentees list are many today. If you didn't wanted, you should have told me, na. Waste of time, yours also, mine also. Have you posted all the test papers?
Roll number 48 is present, ma'am.
Only 2 students have posted the test manual. Sorry, test paper. 1, 2. Kulkarni, A6 and 20. Hmm? See, when you are posting the test paper, say it as test, lab test, SP lab test, and your roll number. I'll rename this. It should be as ST lab paper. Sorry, SP lab test. Like this you do. Somebody has posted me manual or what? I do have the manual. SP lab test. Do like this so that I can identify, because already I have here 6 files. So remaining students do it. Thank you all.
मैंने लैब टेस्ट किया है, देखा है क्या आपने?
Yes.
मैंने लैब टेस्ट किया है.
हाँ हाँ, आपका आया ना उधर. कुलकर्णी आप ही है ना उधर.
जी, मैं देखा है क्या आपने?
हाँ मैंने देखा, आपका एक है और आपका रोल नंबर उधर 65 लिखना था.
हाँ 65.
ठीक है, मैं कर लूंगी.
ठीक है.
मैं कर लूंगी. थैंक यू. Remaining students do it. सभी लोग गए, कोई भी बॉदर नहीं है।